So, thank you, Mr. President, for responding my request. The presentation of this day and related experimental studies on structural, electronic, and optical properties of copper double zinc oxide with 0.03% of copper. Introduction. Soldier technique attracted much attention because of its advantages including safety, low-cost stable deposition equipment of a large area films with uniform thickness. Properties of copper double zinc oxide films have been frequently investigated. Copper dopant has been chosen to enhance properties of zinc oxide hospitality such as crystal quality and conductivity. This study is devoted to fabrication of copper double zinc oxide films with 0.03% of copper and to characterization of its structural, electronic, and optical properties using various techniques. The second one is materials and methods. Copper chloride, zinc acetate, dihydride, ethanol were using as a dopant, source and starting materials and stabilizer respectively. To prepare copper double zinc oxide with 0.03% of copper thin films on glass substrate using solder spin coating method. After starting at 65 degrees Celsius from 2 hours, the solution was then aged at room temperature from 1 day. The solution was deposited on a clean and dry substrate at a rate of 2,800 rpm from 13 seconds. The film were then preheated at 215 for 80 minutes. The obtained films were finally annealed from 1/2 hours at 480 degrees Celsius. The structural properties were characterized using an X-ray diffractometer. The optical parameters were measured by an ultraviolet visible spectrometers in the spectral range 314 and 800. Third one is results and discussion. We begin our results by structural properties. The first figure shows external diffraction patterns of copper double zinc oxide thin films with 0.03 content of copper, and the XRD parent confirms the formation of polycrystalline with hexagonal structural phase of copper double zinc oxide thin films, and no other phases were observed, including the hexagonal versatile structure of zinc oxide thin films isn't altered by copper doping. The 002 plane is found the perforation orientation of grout. The lattice constants are found A equal B equal 3.257 angstrom and C equal 5212 angstrom. The second figure shows the optical transmission spectra of copper double zinc oxide films with 0.03 content of copper. So the transmission spectra of CZO thin films in the wave range 315 and 1000 nanometers were also exploited to deduce the band gap energy. It can be seen that the average transparency of films is about 77% in the visible region. The deduced experimental band gap energy from transmittance is found 3.25 electron volt. Conclusion. Structural results shows that the sample exhibited a polycrystalline with quartzite hexagonal phase. The 002 plane is a perforation orientation The transparency of films presents a high value in the visible region, and the band gap energy makes these films suitable to use into electronic applications. Thank you for attention.